Welcome grade 12s to probability. In the first question, we look at a tree diagram of dependent events. In a bag, there are 9 green marbles and 6 red marbles. That's a total of 15. So a boy withdraws the marbles one by one from the bag and does not return them. The fact that this boy does not return these marbles is what makes these events dependent, because the second draw depends on what the boy withdrew during the first draw. Okay, so let's draw. The tree diagram's already been drawn, and what we want to do is to just put numbers on it. Okay, so we know that there are only 2 colors of marbles in this bag. There's 9 green and 6 red. So we have a total of 15. So in the first draw, you're drawing out of a total of 15 marbles. And of the 15 marbles, we know that 9 are green. So the probability of withdrawing a green marble will be 9 out of 15. And 6 of these marbles are red. So the probability of withdrawing a red marble will be 6 out of 15. That's your first draw. And remember, the colors haven't changed. It's still green and red. Those are the only 2 possibilities. Irrespective of what happened during the first draw, we still only have 2 kinds of marbles, which is green and red. Now, remember, 1 marble has been drawn in the first draw. So in the second draw, you no longer have 15, but you have 14 marbles. Remember, 1 marble has already been withdrawn, so you're left with 14. Okay, so you're left with 14 marbles in your second draw. If you withdrew a green marble during your first draw, how many green marbles are left now? There were 9, but 1 is withdrawn, so there were 8 left. And of course, if you withdraw a green marble in your first draw, nothing has changed with the red marble, so there's still 6. But if you have withdrawn a red marble now in your first draw, remember, then nothing will change with the green marble. There will still be 9. But because you've withdrawn a red marble, the one of those 6 marbles is gone, is withdrawn, so there are 5 red marbles. So that is your tree diagram. Let's go on to the second part of the question. All right. What is the probability that both marbles will not be red? So if both marbles are not red, that means they are both green, right? So here we're actually looking for the probability that the marbles are not red, which is the probability that both marbles are green. So we're looking for green and green. So to calculate that probability is pretty easy. We're looking for green and green. So that probability will be 9 over 15 multiplied by 8 over 14. So if you go to your calculator to check, the answer is 12 over 35. All right, 1.3. All right, so for 1.3, we're looking for the probability that 1 marble is red and the other marble is green. So we're basically looking for 1 red and 1 green. All right, so 1 is red, 1 is green. 1 is red and the other is green. So there are 2 ways to get that probability. Either the first one is green and the last one is red. That's the one way. Or the first one is red and the last one is green. Either way, we've got one red and one green. So let's write out both probabilities. So you want a probability that one is red and the other marble is green. Okay, so looking at the first option, it will be 9/15 multiplied by 6/14. And the next option will be red first, which is 6/15, and then green will be 9/14. And of course, you go to your calculator to work it out. And of course, the solution is 18/35. Let's move now to question 2. Alright, so question 2 is a fundamental accounting principle question. We're trying to make a pin. Remember, it's a 4-digit pin in this case. But this pin will be chosen from a digit of from the 10 digits. Okay, and that is important. Okay, so let's look at the different questions. How many pin codes can be made if the digits can be repeated? And you must always look at the fundamental counting principle from the options that you have. Okay, so you're making a 4-digit pin. And you're going to choose from the 10 digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 0 to 9, you've got 10 digits. So how many options do you have? How many digits do you have to choose from for your first digit in your pin? You can choose from 10. So you've got 10 options to choose from. And we're told that these digits can be repeated. So for your second digit of your pin, you still have 10 options because you can repeat them. Doesn't matter what you chose previously, you will always have 10 options to choose from. Alright, so that means we will have this many pin codes. And of course, this is 10 to the 4, which is equal to 10,000. Now, let's look at the next scenario. In the next scenario, we are told that the digits may not be repeated. Okay? So, when you're making your 4-digit pin, your first digit, you will have 10 choices to choose from. You still have 10 choices to choose from. But now, because these digits may not be repeated, when you choose your second digit, you no longer have 10. Remember, you have chosen one of those 10, so you're left with 9 options to choose from. And in your third digit, you are left with 8 because 2 are gone, and so it goes. So for your 4-digit pin, those will be your options, or the number of pins that you can get. It's 10 times 9 times 8 times 7. 5,040. Moving on to the next part of the question. Alright, so how many pin codes can be made? Of course, these are repeated again. And the code must start with a number that is greater than 4. So looking at your options, how many of these digits are greater than 4? 5 is greater than 4, 6, 7, and 8, and 9. So we've got 5 digits that are greater than 4. So this 4-digit code must start with the digit that's greater than 4. So that means to start off with, you've got 5 options to choose from. There are only 5 digits that are greater than 10. So you've got 5 digits to choose from. Now, what about your second digit? Now, remember again, these digits can be repeated. So it doesn't matter what you chose as your first digit. For your second digit, you still have 10 options to choose from, and for your third digit and for your fourth digit, because the digits can be repeated, and the only restriction here is that this pen needs to start with a number that's greater than 4. So the number of pin codes that could be made in this case will be 5 times 10 times 10 times 10, and of course if you work that out, it'll give you 5,000. Let's move on to the next scenario, which is basically the same, but the only difference now is that the digits may not be repeated. Okay, and then again, remember, we're told that the pin code needs to start with a number that is greater than 5, of which we've got 5 options. Now, because these digits may not be repeated, remember you've chosen one even number. We don't know which one it is, but you've chosen one, and that means you're now left with 9 options. And then you've already chosen 2 numbers, you're left with 8 options. And then finally you're left with 7 options. So the number of pin codes that may be created in this scenario will be 5 times 9 times 8 times 7. Just go to your calculator. 5 times 9. 2,520. 2,520 pin codes can be made in that case. Let us look at the last scenario with as far as our 4-digit pin code is concerned. How many pin codes can be made if the digits, of course, they are repeated again, and the code must start and end with an even number? All right, so how many even numbers do we have here? We've got 2 is an even number, 4 is an even number, 6 is an even number, and 8. So we've got 4 even numbers. So if the code must start with an even number, that means the code will have 4 options to choose from, right? And it must also end with an even number. But because you've chosen one of those 4 even numbers, at the end, you only have 3 even numbers to choose from. Remember, one of them is already chosen, right? And of course, it's exactly the same on this side. The only difference is that this side, the digits can be repeated. So if these digits can be repeated, how many digits do you then have to choose from for your second digit? 10. Remember, because they can be repeated. But on this side, it's a little bit tricky. We know you have a choice of 4 digits in the beginning because we've got 4 even numbers. And if one of those is gone at the end, you're left with 3 even numbers. But now, how many options are you then left with? Remember, that's a number, and that is also a number. So that means you're only left with 8 options because 2 of those numbers were chosen for the beginning and for the end. So, and these digits may not be repeated. So that means you have 8 digits to choose from now. And then for your third digits, you've got 7 digits to choose from. All right, and if we work those out, 4 times 10 is 40. 40 times 10 is 400, and 400 times 3 is 1200. On this side, 4 times 8 is 24. 24 times, let's just use a calculator to save time. So we'll just say 4 times 8 times 7 times 3 will give us 672. So those are the pin codes that we will get from the two different scenarios. So let's go to question 3 now. All right, question 3. We've got Amanda, Lisa, Mondi, John, and Rajesh, who are good friends, and they're going to the movies together. All right, so they will sit next to each other at the movie theater, and let's answer the questions. So how many ways can they sit if they are just set randomly? Okay, all right, and this is similar to the previous question. In the first seat, any of the 5 can sit. In the second seat, remember one's already seated, so there are 4 people to choose from. And in the third seat, and so it goes. Okay, and at the last seat, there will only be 1 person left. So, and again, to work out the different numbers of ways in which they could sit, 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. And 120 times 1 is still 120. So there are 120 ways in which they could sit. All right, how many ways can they sit if Lisa and Amanda insist on sitting together? So if Lisa and Amanda are insisting on sitting together, we've got a bit of a problem, but it's not really a problem. All we have to do, since these two wants to sit together no matter what, we will consider them as one unit. So now, if we consider 2 people as one unit, that means we will just look at them like they're tied together by glue. They're just one person. So that means we've got 4 options at the beginning. If you like, we've got 4 people now because the other 2 are glued together. And we've got 3 options after that, 2 options after that, and then 1. Okay, so that is our situation. 4 times 3 times 2 times 1. But we're not yet done. Remember, we don't know who's sitting on the left, who's sitting on the right between Lisa and Amanda. So we don't know how they're sitting. They could sit either on the left and they could swap. So there are 2 ways in which they could be seated. So we need to multiply those possibilities by 2. All right, so if we work that out, 4 times 3 is 12, and 12 times 2 is 24, and 24 times 1 is still 24, and of course 24 times 2 will give us 48. So there are 48 ways in which they could sit if Lisa and Amanda insist on sitting together. Let's go to the last question now. All right, this is an easy one. Consider the word greet. How many words can be formed from this word if letters are treated as different? Okay, so we don't regard the letters, even the letters that are the same, we regard them as different. So again, it's a matter of choices. How many choices do we have to choose from? In the first instant, we've got 5 words, 5 letters to choose from. 1 is gone, so we've got 4 letters to choose from. Another 1 is gone, and then 3, and then 2, and then 1. All right, so we've got 5 times 4, which is 20. 20 times 3 is 60, and 60 times 2 is 120. 120 times 1 is still 120. So 120 words may be formed. Now, the only difference between this scenario and the next one is here, the letters are treated as identical. All right, and of course, if the letters are treated as identical, remember in greet we have got 2 E's, right? So to factor out the 2 E's, we take the 120, right, of the different options, and we divide it by 2, which would give us 60 words that can be formed if we consider E and E as identical, which they are. So to cancel out the identical, we divide by the 2. Alright, so thank you, grade 12s, and please look out for more examples in your textbook. Thank you.